Hey everyone. So I'm bringing a guest speaker today. Name is Nikhil Mendiratna. Nikhil, you can say hi to the little viewers which I have in my channel.
Hey everyone, nice to be here with you, Niranjan. Thanks for inviting me for a
Yeah,
video.
Nikhil is a dear colleague and a best friend I have, and a pronounced Niagara user. So he's gonna give you some tips and tricks on the Niagara of how it can be useful while you're commissioning or doing your engineering with the Niagara software. So let's get on with the video. Alright, so Nikhil, we're in the Niagara software now, and let's start with a few tidy bitty keyboard shortcuts. Let's not bug down to the real crazy ones just yet. So, what are we going to start on the keyboard shortcuts now?
All right, the one that I love is Control T, which creates a new tab for you, and then you can switch between the tabs while you are working on it. The remain other ones, the thing to note is all the screen shortcuts work on the right hand side, but not on the nav tree. So if I have some VAVs, let's go to wire sheet. And if I select all of them together, then I can use Control R, which gives me a pop-up window to find and replace just like we have it in Excel. I can use Control D. It will replicate a folder or a point, whichever component I am replicating. And then the one that I love is Control L. It gives me a odd of the current page, and I can write my BQL queries or other stuff here to get a required output. So I don't have to get into the program service or report service to get those BQL queries executed.
Yeah, this is cool. So, basically, all Windows shortcuts can be used on the right hand pane of the Niagara, but on the left hand side, it won't be applicable. Let's say if you want to duplicate your VAVs, you cannot just do that on the left hand pane of it. You have to still bring it on to the right side in the wire sheet and then do that.
Yeah.
Yeah, cool. That's some good insight on the keyboard shortcut, which will come in handy while you're commissioning or building up a huge database in your project, which you don't have to go through the pain of clicking mouse clicks here and there. All you have to do is keep your fingers tight on the keyboard, and then it does the magic for you. All right, so now that we have seen the keyboard shortcuts, let's discuss a furthermore bit on how to create a database. As we see now, like, is there a easy way for you to create database if we are talking, let's say, 1,000 devices and for one job site? Is that easy or is that a pain in the ass?
It's a bit easy if you go ahead with the template service and basic Niagara features. And template service anyway can be like it will be a part of the advanced database, which helps in templatizing one. You template one and then have use it replicated, and also you can use like if you make changes in one, then you can also like make updated throughout. But for now, what we are going to cover is a BACnet network. So if we go to the AX BACnet manager, device manager, there is a, if you right click on the view, there is a EDE device manager. So if you click on it and if you hit discover, you can hit add. So there are EDE files which from the BACnet standards are available for each and every system. So which you can take it from a vendor. So what I'm going to do is this is a EDE file and a state location file, which I'm going to import now. And once I do that, hit OK, OK. So you see my device has been discovered, that is offline. And once you do add the device, again, we can rename the device as we wanted. So I will name it as GFL underscore VAV. underscore w underscore 1. Same way I could have renamed and pasted it here. And if it comes to discovering the points, then we can go to ED discovery point manager again, hit discover, choose the one import that I have used, hit OK, and all the points will be here. Now you can add those points and play with all of them, whether you want to change the facet or whether you want to discover, add the point as a writable or an enum, writable or enum readable, same for numeric, change and add them. The activity is similar to what you do on site by connecting to system, but here the advantage is we are discovering them offline and preparing the database before we go on site. Now the
Got it.
only thing, yeah, go ahead.
Yeah. So the basic gist of what I'm getting at is, so for you to import this EDE, let's say you every manufacturer or every vendor you're dealing with, he has to provide you a EDE, which is a backnet standard, and every
Yeah,
programming tool, let's say Honeywell has one, Johnson has one, or let's say other vendors have their own programming tool. They should provide you one as such, which you can import from the same EDE backnet importer, which you just shared, right?
yes.
Okay.
So if we go into the detail of the ED backnet file, so there will be four files. One is EDE, other is state text. Then there are a couple more for units and but what we need only majorly like for Niagara database building is two EDE and state text. Even state text is optional. The advantage of state text is let's go into the state text first and then we'll see the advantages. So it's the database of all the units that have been used in the system. So start, stop, on, off, close, open, false, true, and so on. And same for the enum where we have the all the states available. So when importing the database, these states will be taken care from the state text ED. And if we go to the ED file and have a look at it, so that's all the points up here, the description that we have defined, the object type. So object type is a standard from the backnet. As an example, the numeric point will be 0. Numeric analog input will be 0. Then we have got set point.
Yeah.
So now we have added the database for one VAV. So let's deep dive into the ED files, what they are. So there are four types of ED files, like files which you get from a vendor. One is the ede.csv. Second is state text. The third and the fourth I have not pasted here, which are not required for the Niagara database build, but only for information, it is unit and the object type. So if we go to the ED, so it has the standard name, what date it was taken, and so on. Then the point name, local device, object instance of the controller, object name, which is the point name, object type. So this is how the points are defined in the backnet world. As an example, 0 stands for analog input, then 2 is for analog value, and so on. Similarly, we have 4 for Boolean, and there's a whole list of all the object types which are available in the object type file, which comes as a part of ED. Then we have got object instance, which is nothing but the device instance, the description, the present value, and min-max if it has been defined in the sock, and so on. The only thing that we need to take care is for all the enum points, the present value is defined. As of now, this is a defect, and this is sometimes a manual effort. If the values are not defined, those need to be defined in the Excel. Now, if we go into the state text, so state text references define what are the units like start, stop, stage 1, 2, and so on. For enum points, auto, vmax, vmin, and all the units that have been used in the program. So all this one sheet constitute all the state text references that we have used for Boolean and enum points. And once you have it from the vendor, you can directly import it into the controller. Now, once you have this VAV and you have assigned the facets and so on and placed it, then the easiest way you can duplicate it, or the other way could be you can again have the import of the EDE file into the Niagara database. If you if you duplicate, the only thing that you need to take care is update the device ID and will be all done. So your database for the typical systems will be ready in like 30 minutes or so. And that's how you build a database for 1,000 devices if the systems are typical. If not, then we import the EDE files.
That's great. So basically, once the software is ready, all they have to do is generate an EDE report. If they don't even have to do a manual duplication of the controllers here, everything would still
Right.
be in the report of all the 1,000 controllers. All they do is import that CSV file, and it should bring up each and everything which is in that spreadsheet. So there should be immaculate amount of time that you have to put into the spreadsheet just to make sure everything's right, so that you don't have to fiddle around in the Niagara software here in the crunch time of commissioning to see which points are coming in and which points do not have the state text or something like that. So that should be really helpful building a database. Now, one other thing which we wanted to bring you into focus was changing the units. Let's say your device is giving you a degree Celsius and you want to change it to a degree Fahrenheit. Is there a simple way, or do you have to put in some sort of programming into this in the wiresheet to convert all or feed in the formula? Is there a way, Nikhil?
Yep. So there are 2 to 3 things that we can discuss here. One, if we go into a point, let's say this is SATPS and the software has been developed using degree Celsius. So the value that you would be reading will be in degree Celsius, but your job requirements are degree Fahrenheit. So Niagara has a device facet as a facet. So device facet is something which is it is reading from the controller, and facet is something which it converts. So the easiest way to do it is open the facets and inside the units change it to Fahrenheit, and Niagara will do a automatic conversion for you. So if you notice, read value is 0 degrees Celsius, which is offline, and it has automatically converted into 32-degree Fahrenheit. So that's the beauty of Niagara, and you don't have to write any additional logics or conversions to change the values from degree Celsius to Fahrenheit.
And this is just a tip of the iceberg. It's just not temperature with Celsius and
Yeah.
Fahrenheit. So you can literally think of each and every metric to imperial standard units, and you could start converting them to however you want, be it
Yeah.
energy, be it something else.
Yes. And the another good thing about Niagara is, let's take this example, velocity flow. Here the facet is liter per second. However, due to some reason, like it's just reading liter per second, but a user made a mistake, and instead of liter per second, they changed it to, let's say, solid angle and steradian. And if I hit OK, so it will straight away go into the fault. And if I go to the property sheet and proxy extension, and it will give a fault cause as conversion error. So this is another advantage of Niagara. It tells you real time that you have made a mistake in using the facets and units.
Right. Yep. That's really. I mean, that's you don't have to fiddle around troubleshooting what went wrong. Like it's on the silver platter already for you guys to what went wrong. If we had
Yep.
this thing right, yeah. So that comes in real handy uh, when you guys are doing commissioning as well. Now, are there any other things that we need to show here, or can we boil down to, let's say we have the database, we have all the keyboard shortcuts now, like building a graphic to 1,000 device, that would be some work. Is
Hmm.
there a better way on that one? Let's say VAVs. What kind of VAV have couple of points and the same graphic to those? Like, can we use one single PX file and map it to each and everything, or do we have to have 1,000 files?
So yes, so there are two ways now. Like earlier, the old concept that we used to use was the PX relativization. Now Tritium has brought in the tag relativization as well, new, which we call it NeQuil tags. So the first thing that you need to do in the database is normalize it and have a common names. As an example, this has got GFL, ME, and so on. So I will copy this and I will select all the points and rename, find and replace. So as long as you have all the point names common without any suffix or difference, then we can use them for replication and have one PX file. So if I take this example, duplicate, I'll make it two, and then I'll duplicate it again, and so on. So if I see on the right hand side, the point names are same. This is where I will save a lot of time in the graphics and the database build. So for this purpose, I've already created a VAV with some pseudo points and a PX file, which is a VAV as a common file. And if we go into it, these are all bound odds, absolute odds for VAV1. And if I assign this vav.px copy and vav right click views, new view, I can give it a name vav and provide the path. So vav will be assigned. If I go in here, the only thing that you need to do is edit px, and there's a small button over here in the bound odds, which is called relativize odds. So if you click over here, so it relativizes the name and removes the common path. So the station slot colon driver underscore VAV1 has changed to slot. Station slot colon driver VAV1 underscore airflow has changed to slot colon airflow. So it has removed the common path considering all the odds that we have binded here. Once I hit OK, so now this is a relativized PX. And if I go and copy, the other way could be I will use view, new view, and again assign it. But that would be again a lot of efforts for 1,000 graphics. So instead of that, we will use a very powerful tool which Niagara has, is called Program Services, and which you can access by Services, Program Service, and we will go to Find Objects. So this part is the node or the scope where we define where we want to execute this query. Second part defines what you want to search. So in this case, I'm going to search folder, which is also called the predicate. Then third, I'm going to define what I am going to search. So I'll go in display name and I will type in like VAV start. So it will search all the folders with the name VAV. I will hit OK. So all the VAV folders have come in here. And since I have already assigned the VAV to VAV1, so I will delete it from this view and go to add slot. I will type in the name VAV and Baha PX view. And once I do that, you will see the PXUS come up here, change the view and define the PX file and hit OK. So once I do that, the VAVs have been assigned the PX. And if you notice, wherever the PX wasn't assigned, it has added action add. And wherever it was already assigned, it has redone it and it has assigned the action is set. So if I hit OK, you will notice all the VAVs now have the PX assigned and also with a unique name. So this is how you can do your graphics in bulk. Just create one PX for all the typicals.
That's great. So basically, we have to. I mean, this is a general statement in Niagara. Like to do one single thing, you have numerous ways to do it. It is up to your better judgment which one you find it faster. Like I we find it the programming services real faster since it is just one single action and which defines to each and everything instead of doing 2000 VAVs and assigning a view. So it's up to you guys. If you have good commissioning hours, yeah, just milk it. If not, yeah, use programming service and be done with it. So that was our next topic, anyways, of the programming service. How good of a tool that is in Niagara. Like literally to each and everything you're doing, you can literally go from programming service and like engineer your tool to the to the pioneer of what you're doing. Like the most vital tool which I at least have used throughout my commissioning, like to each and everything. So we'll shed some light on how powerful the programming service tool can be. So for that, like the basic examples we thought of giving you guys was since he showed you the conversion of Celsius to Fahrenheit, you don't have to literally go into individual points to do that. So you have the database. All you got to do is go into programming service, change from one action of all the points which says Celsius to Fahrenheit. Nikhil, if you could just show us how to do that, that'd be great.
Sure. So if we go to program service, I will clear all. And let's take an example of airflow. We are going to change the unit to CFM. Earlier it was liter per second. And if I go to program service, I'll do find objects. I will keep it to config and choose the
All right.
control point.
So let's pause for a real second before we show that. Let's give them a quick idea of in the programming service. What so you literally told them which was predictive and where to find uh, the folder and whatnot, right? So let's just boil down just to give an overview. So let's say in the find, so you can either go to config since we are changing it to each and every freaking point which has lit per second to boil it down to that. But what do we have on the other options? Let's say only if we have to do, let's say only for the air handlers, so only for VAVs or specific to one single VAV which has multiple temperatures or multiple airflow points. So that's from the config window which you see over there. So we
So
could
if you have to change only for VAV1, then we'll just select VAV1. So that defines where our scope is going to be. And all the actions, it is going to search this. Once I execute this query, it's going to be under VAV underscore 1. And then underneath, I can define what I want. Let's narrow down to one VAV, and we have to just modify units of only one VAV and typical points with units, let's say airflow. So what I'll do is I have narrowed down the scope to VAV1. of type, I can either choose control type. So if I choose control type, it will search all Boolean point, enum, and numeric. So in this case, I know I don't have any Boolean or enum point with Airflow. So I will use this control point. And in here, I will choose display name. And either I can use equal or like. So equal, the point name should exact match. And if I'm using like, I can go with wildcards. Either I can use percentage or I can use star. So in this case, I will use flow and I'll put a star in the front and in the back. So let's take the example when I have put a star at the end. So it will only search, it hasn't searched any point because if you look at my database, there is no point where flow is at the start. Like there is, but if I use this star at the end, it has returned 1 point. Now let's do one more thing. Now put star as a wildcard at both the sides. So it has returned all the points where I have flow in it. Just to have a quick view, you have select columns and you can select what point property you want to see, and if you want to see facets, so you can choose facet. This will give you overview what are the current facets. Now if I have to change it to CFM for Imperial, I will click on edit slot, facets, and new value. So in the units, I will go to volumetric flow and change to CFM. Once I do that, hit OK, OK. So all the units have been changed to CFM. So this is one quick way to change the units to CFM. If I have to now do it for all, so I will keep the query as is and will change the query to drivers, like scope drivers, and I will add one more condition for matching, wherein I want only VAV's airflow to be changed to liter per second. So I'm using a query parent.display name where I am defining that the point should have a display name of flow, but it should also have the parent name as VAV. And once I do that, so it will list all the points having parent VAV, and in this case, it's all the folders, 11 VAVs here. And now, simple, I'll go to facets and change it. Instead of now going in and changing the unit by double clicking on config facets, I will use the recent, and the most recent that I have used will appear and I can do it quickly. So all the units are done. One thing to note, whatever points appear, I'll give you another example. I've seen a lot of people make this mistake. Discover again. People assume that the points that they are selecting will only get impacted in the program service, and they make the changes. And let's say change the unit to liter per second again. And assuming the points that they have selected will only get impacted, their units will change and the remaining will remain as is. However, but what you will notice is all the points or components that were part of the program service discovered will have the units change. So whatever components you don't need, delete them from the program service and then make the required changes. Another trick that I generally use is find objects. Let's say I'll use a different name. One we will use room temp, and the other we will use is effective and occupied cooling set point. So all these 4 points have got a unit of degree Celsius. So Instead of defining, I will use display name, define it here, like change this as room temp, OCC, cooling SP. It's not just one point that we can discover here. And again, I will paste display name like OCC HTGSP. And the only thing to change here is the condition match, which means all the conditions should match. So it will search for a control point where the display name is room temp, occupied cooling set point, and heating set point, which won't give you an answer. But what we are going to change it to is any. So this will be or condition. And once you hit OK, so if either of the conditions match, the points will be listed. And if you have noticed, even it has discovered the points of the occupied cooling set point from the VAV, which we created at the start of the session in the BECnet network. Because our scope was defined at the drivers level instead of any particular VAV or config level. So these are some basic tricks which you need to follow in the program services. And there is a lot more that can be done. Maybe adding histories or editing histories or updating slot flags, etc., etc.
Yep, yep. So, yeah, the general purpose of us using, for the most part, is to add the alarms in bulk, or edit histories, or to change facets like this, or to uh, fine tune our policies on the points as well. Uh, so basically, one other thing which I want to highlight in here is, and yes, you might clarify on this one as well, Nikhil. Is there a Bible? So we were looking at a lot of um, conditions over there, right?
Hmm.
So for a rookie who comes in, he doesn't know what a display name is.
Hmm.
So is there a Bible to him where he can look into what his command should be to get into the batch editor for displaying all of this?
Okay. This is a very good question, and I've learned it. Uh, and it was a beautiful thing that I came across. So one of the thing is, if you want to search whatever you want to search, go to that parent and open the slot sheet. So the control, the type that we define in the program service here is essentially defined in the slot sheet. So if you notice, we have defined control, enum writable, and so on. Now let's say take an example where I want to dig deep further, and I will go to the slot sheet of this point. So it has got, I think it's a bad example. Let's go to BECnet network, VAVs, and I'll go to this point and go to AX slot sheet. Now let's assume I want to change the conversion in the proxy extension. Let's assume this is conversion here. Instead of default, I want to use linear, or I want to change the tuning policy or something like that. So the easiest way to find is, if you notice, the proxy extension has a type control colon abstract proxy extension. Now if I go to proxy program service, find objects, I will get rid all of this, and control point, instead of this I am going to use custom type, and it has got all the components available in Niagara. So if I search control and if I search abstract proxy extension, and I will add some detail, let's say instead of display name, I will have to use parent dot display name here, since the display name of the point will be proxy extension, and I will define it as SATPS. So once I do that, so there are 3 points where the parent dot display name was SATPS, and I can see by select columns, what is the object ID, what is the tuning policy, and whatnot. Now, let's say I have to change the object ID. I found out later that due to some programming changes, this has been changed. So what I'll do is edit slot, go to object ID, and instead of 3, I want to make it 5. So that's how easy it is. And the only way to find out is using the slot sheet. This is the best, this is a best way to find out, even during the histories, finding the PX views, etc. etc. So once you start playing with the AX slot sheet and then try a couple of examples with program service, it will make your life a lot easier.
That is true. That is true. I'm the living witness of that. Uh, yes, programming service has made my life easy in a lot of jobs. Uh, we were talking about tuning policies as well, which I definitely want to shed some light on that. So basically, tuning policies is used to control your traffic. You will have sites, or you might be facing issue on your site saying, hey, the points aren't coming as quick as you're seeing in your own controller, um, in your monitoring tool, or whatever you use. The values have changed, but I'm not seeing that value change in the Niagara or on your front end right now. Why is that happening? Why is that happening? So basically, if you have a larger network and you have all the devices, say you have probably 10,000 temperature sensors, and then you say all the temperature sensors to change value every every 5 seconds. Just imagine how many packets that would be sending to one single node from all those controllers coming in. So tuning policies is onto those to which you want to reflect faster and to control the traffic, saying, hey, you come in quick as soon as you change values. And for the few monitoring points which are not critical enough, you can define the policy saying, hey, you're not that important to me, you can just reflect the point coming in at a later stage. It's not life dependent on you. So something like that. So yeah, Nikhil, if you could just shed some light on how to define policies, and then uh, as he showed you on the earlier stage, just go to the programming service, and to whatever points you need, you can change the tuning policies on the go in one single action. So yeah, go ahead, Nicole, take it off.
The way you explained it, Ranjan, I have a good analogy that I generally take for defining the Turing policy and the traffic. So I generally consider it as an expressway with 3 lanes,
Mm-hmm.
and Niagara always defines. I'll just go to the IP port and pole service here. The first thing. So here we define the fast rate, normal rate, and slow rate. So I generally consider it as a express highway where fast rate is the fast lane, which is on the right hand side, then normal in center, and the slowest vehicle always move in the last lane. So the way we do it on the expressway, we need to do it same in the Niagara. It's no different since it's pooling. If we, there is another feature which is COV, so that's also defined as a part of the tuning policy and defines how the point will get the data. So as per experience in multiple sites, generally we keep this fast rate as 7 seconds, normal rate as 31, and slow rate as 1 minute 30 seconds as a starting point. And what I have done, the reason I have chosen this number are these are all prime numbers. So 7, 31, and 1 minute 30 seconds, which is 90. So there are very less chances that these are going to conflict anywhere. So as a starting point, I define these, and then I'll go into the tuning policy under BACnet network. And what I'll do is I'll duplicate and name one as fast, other as slow. So few components of the tuning policy, write on start, write on up, and write on enable. So these define when the controllers are going to come online or when JS is going let's say JS is rebooted, then what action happens? So if all these values are enabled, so it will write the value from JS to the controller, so that whenever there's a reboot of the controller or the JS, then these values are written from the controller, JS controller or supervisor to the backnet controller. Then we have got a pole frequency, which we were discussing prior to this, where there are three options available: fast, normal, and slow. So generally, as a thumb rule for fast, I keep the points like pressure, Boolean inputs, alarms. These are high value points which need to be updated in my system mm, as and when they are generated. So alarms are critical. If the fan has started, then I need the status instantly on my system. Slow, I go for the points which do not update quite often, like alarm set points, occupied cooling set points, airflow set points, and so on. So even if they are, if user has updated them, maybe, and if like maybe, and that would be once in a while if they have updated that, and if it does not reflect in the system for maybe let's say 10 seconds or 15 seconds later, it doesn't impact my performance of the system. So that's why all the set points majorly go in the slow. Normal, I prefer to have the temperature sensors and maybe effective temperature set points and so on in the normal. So this is the thumb rule which I go by. And the other option that is available here is use COV. So instead of going with polling, you can use the COV option, make it true. But in that case, the only thing that you need to make a note of it is there is a COV property increment. So you need to define the COV property increment for individual type of point. As an example, the temperature could be, let's say, 0.2 that you want a COV increment, then the value should update. But for a pressure, the value will vary, and for other points. So in that case, you will have to create multiple tuning policies. So once you do that, we'll stick to pole frequency in this case and not the COV. So once you do that, normal, with thumb rule, we will assign the points. I'll make it as fast here and slow. The other thing that we need to take care is all the points that are there in system should be equally segregated into three tuning policies. Let's say we have got fast, slow, and normal, and the number of points we have got is 100. So what I will try is to have 35, 35, and 30 points or somewhere around that, so that there's an equal distribution. Now there are two ways to change it. So one, it comes as a part of the proxy extension, and I can go and manually change the value. Let's say it's a pressure, so I'll make it true, fast. Other way could be I can have the tuning policy names display here, and I'll sort it based on the facets. I'll add a facets here as well. It's a bit difficult to sort it. So what I'll do is I'll sort it based on the out. So I have got all the set points. So I will select all of them here. Let's all these and go to edit and change the tuning policy to maybe slow. So this is one way, but the problem here is I cannot do it for all the controllers or all the points in my station. Again, a solution, we head back to the program service. Once I go to the program service, I'll search, let's do that. All the points with SP. So I will use my last query using the recent block where I have done control abstract proxy extension parent.display. Instead of equal, I'm going to use star SP. So whichever points have got set point in their name, I will search them here. So all the points are available, and you can see the tuning policy has been defined as slow in few cases, which I did using the BACnet point manager view, or the default. Now I'll click on edit slot. and tuning policy name. Now the trick here is it doesn't display the drop down values. So you'll have to manually type them. And once you do, so all the values have been changed to slow. And if you notice here in the points, so you will see a lot of values have changed to slow. We'll take another example since we have made some minor changes here. So all the set points have been changed to slow. So this is a quick way to change it. And when on site, to determine how your system is performing, you can go to BACnet.com, network. If it's a IP port, go to IP port poll service. If it's a MSTP port, then you go to MSTP poll service, and you will see the busy time here, normal polls, and all that data, fast cycle time, and overall how much we are consuming. If the busy time is more, that means your system needs to slow down. Generally, I try to keep it to 15 to 20%, which is also on a higher side. It should be even further lower. So this was majorly on the tuning policy and tuning your system for site, and you will have to find a sweet spot per your site conditions. The numbers cannot be same, and this activity has to be done for all the sites, whether you want it or not.
That's right. That's so true. I mean, this defines how your front end is going to interact with you, and this is like tuning a one goddamn pump which is going to hunt you through with its PID. So you're gonna find that sweet spot yourself while crunching in those numbers based on how you have put in the tuning policies and how effectively you have utilized that in your points as well. So if you have on the pressure, if you have very fast rate policies, then no matter how much you tune, it's still going to affect if the number of points is much higher than the slow rate and the normal rate. So yeah, so this is basically a few things which we wanted to bring in for the Niagara commissioning as tips and tricks. Um, you got anything else on the top of your head, or are we good to end the show?
I think just one thing on the conversion unit. So if you are doubtful, then you can go to git control, and in the conversions, so Niagara has given a numeric unit converter here, and you can use this as well to find the desired output if it's not a proxy point.
Mm-hmm.
So the normal Niagara points that we create, they don't have a proxy extension. So this won't work there. But if you want an easy fix without any formulas,
Just
then
use
you
it
can
on
use
the
numeric
worksheet, yeah.
converter. And this is quite useful when you are doing conversion of minutes to seconds and
Yeah, yeah.
milliseconds instead of using the multiplication, which is quite confusing to come up with 60 into 1000 is
Mm-hmm.
60,000 milliseconds and so on. So that makes your life a bit easy.
True, true. Yep. So this was tips and tricks for the Niagara. We did wanted to cover the programming aspect, but we figured that's gonna go longer than this. So stay tuned for another video while we talk on the programming as well. That's gonna be a fun session too. Um, yeah, thanks to Nicole for sharing your insights and all your tips and tricks. I hope the commissioning engineer is going to be thanking you uh, for this. All right. So thanks, people.